Okay, so this lesson is going to talk about factoring a quadratic ax squared plus bx plus c by grouping, where your a value, your leading coefficient, is not equal to 1. So we cannot use the same method that we did before, so what we're going to do is learn a new method how to factor by grouping. So we're going to do this by example. I take a look at my first example. It says 2x squared plus 7x plus 3. The first thing I want to do is multiply my leading coefficient by my constant. Okay, so 2 times 3 is equal to 6. All right, now we need to find two numbers that multiply to 6, what we just got, but add to 7, which is our middle term here. So if I say 6 and 1, because 6 times 1 is equal to 6, and 6 plus 1 is equal to 7. Now, if you have a hard time figuring that out, you can list all the multiples of the number you're looking for. So we know that 1 times 6 is equal to 6, and 2 times 3 is equal to 6. Out of these two pairs, which ones add up to 7? 1 plus 6. That's how you decide which ones work. So, what I'm going to do now is I'm going to rewrite this 7x by using 6x plus 1x. So if I rewrite my problem, 2x squared plus 6x plus 1x plus 3. So I took my 7x and I made it 6x plus 1x, which is the same as 7x. I'm just rewriting it. Again, we have our leading coefficient here, and we have our constant on the end. Okay, so now what I'm going to do is I'm going to do what's called factor by grouping. I'm going to make two groups. Okay, I'm going to make a group out of my first two terms, and I'm going to make a group out of my second two terms. Okay. By doing this, I want to determine what numbers or letters each group has in common. We're going to factor out our greatest common factor, our GCF. So, looking in my first group, 2x squared plus 6, what does both 2x squared and 6x have in common? Well, they both have a 2. Oops, let's change the color. They both have a 2, and they both have an x. So, if I factor out a 2x times what is 2x squared? 2x times x. 2x times what is 6x? 3. Now I look in my second group. Notice I put my sign in here with me. So I have a positive 1x and a positive 3. Do positive 1x and positive 3 have anything in common besides 1? They don't. So I just write plus 1 because that's the greatest common factor I have, 1. X plus 3. Now notice that 1x and x mean the same thing. Okay, now I have two groups. I have this group, 2x plus 3, 2x times x plus 3, and I have this group, 1 times x plus 3. What do both of these groups have in common? They both have an x plus 3. So because these both groups have an x plus 3 in common, I can factor that out. If I take out an x plus 3 from my first group, if this goes away, I'm left with 2x. If I take out an x plus 3 from my second group, what am I left with? A 1. This becomes my final answer of factoring. Now you might say, how do I know in my problem if I write it 6x plus 1x or 1x plus 6x? It doesn't matter, and let me show you why. So let's rewrite our problem and try this again. We have 2x squared plus 1x plus 6x plus 3. Again, if I make my two groups, here's my first group with my first two terms, and my second group with my second two terms. I ask myself the question, okay, what does 2x squared and 1x have in common? 2 and 1, they don't have any coefficients in common, but they both have x's. So if I take out an x times 2x is equal to 2x squared, and x times 1 is equal to 1x. What about in my next group? What do both of these have in common? What is their GCF? 6x and 3. They both have a 3 in common, a positive 3 in fact. So if I take out a positive 3, 3 times how much is 6x? 3 times 2x. And 3 times how much is 3? 1. Again, if I now look at my two groups, I have this first group and this second group. What do both of these groups have the same? They both have a 2x plus 1. So if I take out the 2x plus 1, if I factor it out, my first group I'm left with an x, and my second group I'm left with a 3. And this is my final answer. So my question is, are these the same? Well, to answer that question, let me ask you, is 2 times 3 the same as 3 times 2? They both equal 6. So the only thing that's different from here all the way to here is the order in which you multiply your groups. And since when you're doing multiplication, order does not matter, these are both the same answer. So when you're doing these problems, it doesn't matter when you rewrite them if you rewrite it as 6x plus 1x, or if you rewrite it like we did here as 1x plus 6x. You get the same answer. Let's try another one. Okay, 6x squared minus 5x minus 4. So the first thing I do, if we look back here, we have our leading coefficient. We have, this is a negative 5 for our middle term, and we have a negative 4 for our constant. We want to multiply our leading coefficient times our constant. 6 times negative 4 gives me negative 24. Okay, so I need to multiply to negative 24, but I have to add to my middle term. I wanted to add to negative 5. So the best way to do this is to list out all the factors of 24. So I can do a positive 1 times a negative 24, or I can do a negative 1 times a positive 24. 2 times 12, or 2 times negative 12 is negative 24, or negative 2 times positive 12. I could do a positive 3 times a negative 8, or a negative 3 times a positive 8. I can do a positive 4 times a negative 6, or negative 4 times a positive 6. Those are going to give me all my factors of negative 24. Now I want to choose the two that add to negative 5. Not this one, not this one, not this one, not this one. This one looks promising. 3 minus 8, or 3 plus a negative 8, is equal to negative 5. So 3 and negative 8 are the two that I'm going to use. So I'm going to rewrite my problem. We have 6x squared plus 3x minus 8x minus 4. Okay, so again, we look here, we have our leading coefficient, which is the same. We chose to rewrite negative 5x as positive 3x minus 8x, and then we have our constant, negative 4. Okay, now we're going to split this up into two groups. So here's my first group, and here's my second group. Notice I include my sign here. Okay, in my first group, I want to know what is the greatest common factor. What do both of these have in common? All right, so they both have 6 and a 3. 3 goes into both of those. Oops, wrong color. And an x goes into both of those. Okay, so 3x times how much is 3x times how much is 6x squared? 3 times 2 is 6, and x times x is x squared. And 3x times how much is 3x? Just a plain old 1. Now, I always want to make sure that this is not negative. So I'm going to have to factor out a negative number. So what has negative 8x and negative 4 have in common? They both have in common a negative 4. So negative 4 times how much is negative 8x? A positive 2x. And negative 4 times how much is negative 4? Positive 1. When you're doing factor by grouping, you should always get a group that's the same in each one of your terms. Okay? So now I want to say, what's my group that's the same? 2x plus 1 is the same. So I factor it out. What am I left with in my first group? I'm left with a 3x. What am I left with in my second group? Negative 4. Now, does it matter if I rewrote this as 6x squared minus 8x plus 3x minus 4. It does not matter. It will get you the same answer. Let me show you. If I do my factor by grouping, okay. What do 6x squared and 8x have in common? What number goes into both 6 and 8? 2. And they both have an x in common. So 2 times 3 is 6, and x times x is x squared. And 2 times negative 4 is 8. Okay, what do 3x and negative 4 have in common? They have nothing. They just have a regular old 1. 3x minus 4. Okay, so now here are my two groups. One group, two group. They both have in common a 3x minus 4. So in my first group, if I take out a 3x minus 4, what am I left with? 2x. In my next group, if I take out a 3x minus 4, I'm left with a positive 1. So we're looking at this answer and this answer. Again, I'm just multiplying them in a different order, so I still end up with my same answer. My factors are 2x plus 1 and 3x minus 4. If you have any other questions, let me know.